Okay, in this video, we want to solve the following initial value problem using the Laplace transform. This is one video. In the next video, I'll solve it in a more traditional way. And so we have y double prime plus 3y prime plus 2y is equal to 0, where y parentheses 0 is equal to 1, and y prime 0 is equal to 0. And so this method I'm going to do is actually a shortcut. You probably won't see it in your classroom, but it's pretty quick. So we say ys is equal to, in the denominator, we would say s squared plus 3s plus 2. For like second order differential equations, we would say like r squared plus 3r plus 2. Instead, we say s squared plus 3s plus 2. And this would be in the denominator. And in the numerator, we first ignore this plus 2, and we focus on s squared plus 3s, and we divide by s. So dividing by s for s squared plus 3s, we would get s plus 3, and in the next line, we multiply this by this number right here, 1. Y parentheses 0 is equal to 1. So we multiply by this 1. Next we say plus, like what we did for here, we say we ignore this plus 3, and we get s, and we divide by s. So we say s divided by s would give us 1 times, we have 0 here. So y prime 0 is equal to 0. So we choose this 0 right here. Plus this value here. Since it's a homogeneous equation, it's going to be 0. But if it was a non-homogeneous equation, we would put this value. So I'll just say plus 0 for this. And we will clear it out a little bit, so we can say ys is equal to 1 times 0 is 0, plus 0 is also 0. So we would get s plus 3 divided by, I'm going to scroll down a little bit. And so we can factor this out, and so we would get s plus 2 divided by, s plus 2 times s plus 1, like this. And we will say, since we're going to look at this table right here, the form that we have isn't anything like this. So we need to make what we have into something similar to this. And so we can do that if we say a divided by s plus 2 plus b divided by s plus 1. And so we need to get a and b. But by having it in this form, it's going to be similar to this, because 1 divided by s minus a, and so 1 divided by s minus a. So we can say s minus parentheses minus 2, likewise s minus parentheses minus 1, and so we can, our answer will be something like this, e raised to at. So we'll do that. And so the next thing that we're going to do is multiply everything by s plus 2 times s plus 1. So we will clear out the common denominator. And so what we're going to get here is s plus 3 is equal to a times s plus 1 plus b s plus 2. And if we say that s is equal to negative 1 or s is equal to negative 2, we can get our a and b. And so if we plug in negative 1 for s, what we're going to get is minus 1 plus 3. So that would be 2 is equal to minus 1 plus 1 is 0. So this would be 0. So we would get b minus 1 plus 2 is going to be 1. And so b is equal to 2. And then we do the same thing for s is equal to negative 2. So minus 2 plus 3 is going to give us 1 is equal to a times minus 2 plus 1, so minus 1. And this right here would be 0. And so a is equal to negative 1. So I'm going to scroll down a little bit. And so we would get ys is equal to minus 1 times 1 divided by s plus 2 plus 2 times 1 divided by s plus 1. And by having it in this form now, it's going to be very close to this. E raised to at is equal to like 1 divided by s minus a. And so what we have is 1 divided by s minus parentheses minus 2 and 1 divided by s minus parentheses minus 1. And so in both of these cases, a is going to be negative 2 for this, and a is going to be negative 1 here. And so our final answer will be t is equal to negative e raised to negative 2t. Negative here is because of negative 1. Plus 2e raised to negative t. And this right here is our final answer. And that's all we need to do.